Hi there. Today we're going to be having a look at Delphi records. Delphi records are a compound data type that you get to make yourself, and it allows you to construct something that looks a little bit like a database record. And we'll talk about databases a little later in the course. If you have a look at your assignment page, you'll find our first assignment. You'll notice that there are two that have the same topic. The first one, movie database, and then VPL, movie database. It's the same assignment, but in two different environments. To illustrate the way the same code works in the two different environments, we'll be going through both of these activities today. I'll begin with the Delphi version, which you find here. And you'll see towards the bottom of the screen that there's a zipped folder that you're going to have to extract under your projects folder, as I have done here. You're provided with a project movies, contains one form search, which will provide the interface, and then your movie data itself, which is stored in this mock movie data CSV. CSV stands for comma separated values. And if you look at the values, find that each line is a movie title, followed by a comma, followed by a genre, and then a date, and then a length. All right, so let's open the movie project. Here. Our interface screen is this one. Let's begin with the list button. But the question starts with create a record structure to represent the data in the mock movie dataset. And you'll find that our record structure has got to contain these four items: a title, a genre, a year, and a length or running time. This will have to form part of the main code. So we go to the beginning. Records are created under the type section of your program. So under type, I'm going to start with my record. I'm not given any particular requirements in terms of names, so I can choose my own. I'm going to call this T movie record, and it's going to be of type record. Right. Notice that Delphi has provided the little end for me already. Now, our data structure is going to be constructed between those two lines. Again, with the title, and the title will be a string. That we're going to add the genre. And we're also going to add the year and the running time. Now, this particular set of questions only asks for display. Have a look at the questions. You're not asked to use the length or the year in any particular calculation. So I could, for the purposes of this project, just use strings for all types. But to illustrate that a compound type can contain a number of different types, I'm going to make year an integer, and we'll make the running time an integer as well. We'll measure it in minutes in this case. So let's call it length. Just like with variable declarations, I could separate these with commas instead of repeating string, string, integer, integer the whole time, and do that as long as they are the same type. Right, there is our record structure. The next part of the question is create an array to represent this. This is going to have to be a global variable because I'm going to need to access it from all parts of the program. So there's my array movies. A regular array, if I was making an array of strings, would take the format something like this. Array. I'm going to assume that there are going to be an awful lot of these, so 2,000 of string, and that would create an array of 1,000 strings. In this instance, I don't want to use strings. I want to use my T movie record that I have just created, just above here under the type section. So that's what I'm going to say, T movie rec. And I now have an array that can contain 1,000 movie records. The next portion of this question is going to be, we need to load the movie data. And this is going to be the same file operation as I would have used if I was trying to populate an array of strings. The only slight addition is that I'm now going to be splitting each line from that text file and putting the appropriate information into my record. You can also have a file of records which will make that a little bit more automatic, but for the purposes of these exercises we're going to work with regular text files. This is going to have to form part of the form create event. There's no button that has been created to load a particular file, so this is going to happen automatically when the program starts up, when the form is created. Yeah. Alright. You'll know from your previous exercises working with files we're going to need a few variables. First one is some connector file variable, which I'll call con. We're going to need an integer counter because I'm going to have to add each value to a new array cell indexed by that counter, be an integer. And to be able to extract the fields, I'm going to have to do the usual pos, copy, delete business that you've been doing since grade 10. So I'll need, at the very least, a variable to indicate position of the comma that does separation in the comma separated value file. I'll need a line, which I'm going to read from the file, and a few other variables potentially to control this separation. But let's start with that. It's always a good idea to check whether the file actually exists, so we'll begin with that as well. The file's name, see, was mock movie data. I'm going to copy that. And I prefer to handle each case individually. In this case, I'm going to handle what happens if the file does not exist, which allows me to exit this routine and carry on with life, rather than having to build a complicated hierarchy of if statements to manage this. So, show message. Some useful feedback and exit this routine. Now everything below this will be what we do if the file does exist. Okay, sign file. File's name again. We're going to reset this for reading, and we're going to do this while we haven't reached the end of the file. Always close the file. Right, that takes care of the basic reading the file and maintenance portions. Now we have to do something with this line. And what we're going to have to do is separate each value from that file. If we have a look at our file again, we're going to have to split out each name from the comma, from the genre, from the year, from the length. So let's go about that process. And this is the regular pos, copy, delete exercise that you have done ad nauseum at this point in your life. So we're separating on the comma in S line, and I can store this directly into one of my array cells. In this particular case, it's AR movies, and my counter is CNT dot title, because I'm starting with a title. Copy from S line, starting at the first character, and I want to copy P-1 characters. and then we delete including the comma. All right, that gives us the title stored in that particular field. We can duplicate this a few times to extract the other fields that we need. The second one was the genre, and then we have the year. Remember, the year was stored as an integer, so I'm also going to have to convert this into an integer. And by the time we get down here, all that's left in S-line is the length. Which would work fine if that was actually stored as an integer. But it's not. S-line, the length, remember, is now stored as hours and minutes. So to be able to do this conversion, to store this as minutes, I've complicated matters for myself here by trying to store it this way. I'm going to have to take the hours, convert that into minutes, and work with that. So we can do exactly the same thing. P equals, this time I'm looking for the colon in S-line. Let me give myself a variable to store this. I'll call this S hours. I've made life a little difficult for myself because the length is stored as hours colon minutes. So I need to convert this to a runtime in minutes to be able to store this as an integer, which means I'm going to have to do a bit more. Pause, copy and delete. This time we're looking for the colon in S-line. I'm going to store that in a little variable that we create specifically for the purpose, call S hours. And delete to reveal just the minutes portion. So my length can now be the hours portion times 60 plus what's left in S-line, which is the minutes portion. And there we have our whole record populated. The last little bit, right now, I am not working with count. I haven't initialized it. We must always initialize our variables. My array starts at 1, so I'm going to initialize count to 1. And we'll have to go on to the next record in the array, so we must increment count. And there we are. It might also be useful later on when I'm trying to process this and display everything. It might be useful to know how many records I've actually read. At the moment I've got an array that can hold 1,000, but I don't necessarily want to display 1,000 lines if I only have 5 records in the database. So I'm going to add another global variable. Let's call it record length. And I'm going to use this to store the number of items that I read. Again, count at the moment increments at the end of this routine, so it'll always be one more than the number of records actually read. count actually represents the next open space in my array. We'll take a step back for the record length. That now contains the number of records I have actually got in my movie database. Right, we've now opened this particular file. We've handled splitting this and populating our array. We can now list the whole lot. So let's do our list button. I'll be using a for loop to run through the whole array. We've got a known number of items, and we're not trying to do any processing, we're not trying to do any searching or do any selecting based on a particular value inside this. So a for loop is the ideal target. Clear the rich edit where we're going to be placing these values. For my x value of 1, 2, and it's just as well that I made track of how many records I had in the array. Now we're going to use that. But not -1, because that assumes your array starts at 0. Okay, I'm going to make another variable to store the line as I build this. I want to output this as one line. So this line equals line, in this case, dot title. I'm going to add a hash 9, that represents a tab character. And then we're going to add our next field to what's already in sline. Add the hash character again. Year at the moment is an integer value, so I'm going to have to convert this to a string for display. Other hash 9, and the last one will be the runtime, which is also an integer, so I'm going to have to convert that to a string as well. And just to make this a little fancy, say that it's in minutes. And there we go. So let's see if this works. We haven't yet tested this program. We'll check to see whether the file reads correctly. And it tells us that year is not an integer value. Now remember, this is from our input. This is, if we break quickly and stop the program, that's converting something to an integer, and what it's trying to convert is the value year. Have a look at our input file, you'll see that the first line doesn't contain the data that we're going to be processing, it contains column headings. So I need to get rid of that first line before I start doing my processing. I'm coming back to my reset. I'm going to take a simple little cheat. In a more thorough version of the program, you would use those column headings to determine the fields, and that would allow you to be more flexible in your data store. You could swap the order of the columns and everything would still work. But here, I'm just going to throw that value away. So we're going to read a line and discard it. I'm not going to process that in any way. runs. All right, it runs, but at the moment we don't have any display, and that's because I've forgotten something fairly obvious. We actually have to send this line to the rich edit. It's not enough just to build the line. There's one. We also have to add the data. And there we go. Right, it's not formatted very nicely. This doesn't form part of anything that you're required to do, but if you want to split the columns up a little bit nicer, have things arranged in columns, Windows does have this as a part of a rich edit. You can have an array of tabs. Let's call it tab array. I'm going to have 3 tabs between the title and the genre and year and length. So this is going to be an array 0 to 2 of integer. And we can define particular places for this. The titles can be fairly long, so we'll make this 300 pixels wide. Genre is not as long, so we'll make it 150 pixels wide. Year is quite short, let's make that 50 pixels wide. Those are the 3 points at which I'm going to be placing tabs. That would be 500. And now we have to send a message to Windows to actually add these to our rich edit. That works this way. Send message. We're going to have to refer to the name of the control in Windows. This is how Windows thinks of the control, which you'll see there is this type, hwind, that stands for handle. Handle of our rich edit. So rich edit 1.handle. There we go. And the message we want to send is em set tab stops. That's a constant, a predefined value that Windows knows as an instruction to set tab stops for your rich edit. We're going to then tell it that we're going to be setting 3 tabs, and we're going to have to give it the address of this array. Windows expects a long int. Now, what we're doing here is telling telling the operating system to interpret the array that we're sending them as long integers. And that says use the address of the array. You don't have to remember that. All right, we're not allowed to do that here. So just for this, I'm going to make that a global variable. And there we are. Things aren't aligned at the moment because my dialog box is too small. Move it a bit wider, and there we go. All nicely arranged in columns. Right, let's have a look at the last part. Now, the last part of this question, add a search option which enables users to search for a movie by title and display this formatted in the rich edit. It doesn't say how we're going to format it, so we'll make this up as we go along. Right, let's go to search. The search function is going to use this button here. We're going to process the array. So I will need some sort of index counter which will enable me to go through the array. We're going to be using a standard search algorithm. So while, and we're searching for AR movies. Title, the first one, is different to the edit box here. Search is, edit box is edit 1. So edit 1 would have been better to give it a name, but we'll work with the default. And that would carry on until something typed in edit 1 matches the title. Of course, it's very easy to type something incorrectly or use a title which doesn't exist in our database, and then this would carry on without stopping. So I also need to account for that particular possibility. So and I is less than, we're going to use that global variable we created, which records the length of our movie database. There we go. Now I've got two particular points at which this routine can exit. It can exit when I've found the movie title, or it can exit when I've run out of movie titles. So I'm going to have to check for which one actually happened in this particular case. I'm going to check this particular example. If I've found the movie, then we now construct our formatted string. Or, following the same principle that I used earlier when I was testing whether the file exists, I can check to see whether they're different, and give a little message and exit. Right. So what I have below here is now, at this point, I know the file exists, and I can worry about formatting it and displaying this. Let's clear the rich edit again. And I'm going to create this as a set of 4 lines. So rich edit 1.lines.add. Let's add the string title plus AR movies by title. Genre. Genre, and the same again for length and year. Again, remembering that this is an integer. So I'm going to have to convert this into a string. There we go. And the same thing, don't forget the semicolons, and the same thing for the length. Which, again, just to doll this up a little bit, I'm going to say is done in minutes. And there we go. Let's see if that works. First, would be good to resize this so I don't have to keep doing that. And let's see if we can get information about Lucy, something nice and short. And oopsie. And what we're getting is a lesson in why you must always initialize your variables. Right? What this says is we're trying to access a location in memory that has not been allocated. It's telling me that it's here. This actually happened in the very first line of execution because I did not initialize I. This instance, I could well be a 0, and remember my array starts at 1, and that is not very useful. So I equals 1, set it to a known starting point, and then you know you won't run into those problems. Let's test Lucy again. Lucy And there we go, data for Lucy. So that's how we can use a record to construct a very elementary, basic database. Each record would represent one row in a database table, and we can use structures like this to represent fairly complicated data. In the next video, I'll have a look at trying to implement this in a console application, and we can compare the two versions. So, until next time, bye for now.